All right, so you've seen the title. So if you've been here, you've seen the title. I'm not going to go on about it. Here's the idea. What I want to talk about is common backup problems. I want to talk about them. I want to tell some stories. The reason I know a lot of these common backup problems is because I've either done them myself or I've had to recover from someone else doing them. So I'm more than happy to share my horrific, nightmarish screw-ups so that maybe, just maybe, you guys don't make the same mistakes. That's the plan here. Be the negative example so you guys don't have to follow along. We want to find ways to prevent these things from occurring. And I'm going to make a lot of suggestions. The basic context that we're going to walk through is I'm going to tell you what the problem is, why it occurs. I'm going to tell you what the indications are that you're having that problem. And then we're going to talk about ways to solve it. So hopefully all of that information will accumulate and be useful to you, and we'll get going. Now, for those who don't know me, my name is Grant Fritchey. I work for Redgate Software. I'm a Microsoft Data Platform MVP. I've written several books, including an introductory book on SQL Server. I'm very excited about SQL Server. I've been working with it and learning it for years and years. And so I really love to share this information with it because I've had a great career with it, and I think more people can have that same great career. So very excited about talking about it. After today, if you have questions, this is my contact information. You've now got my Twitter handle, you've got my direct email address, and you have personal invitation to use it. If you've got questions after today, track me down, ask me. I want to help. That's what I'm here for. I try to help out. Also, that's my blog, a lot of information on there. Some of it's introductory, some of it's not. I'm the intermediate guy. I'm not the advanced person. There are much smarter people than me. I lift everyone up to intermediate and then pass you on to the smart people. That's just how I do things. So our agenda today, we are going to talk about the importance of disaster recovery because disaster recovery is extremely important. It's a fundamental part of your job as, I don't want to say database administrator. That role is, that title is somewhat dying, not the role, the title is dying. Data engineers, all kinds of other titles are coming into more and more vogue. But disaster recovery is really important for people who are responsible for data and data management. We're going to talk about backups. We're going to talk about the issues with files and the way files work. We're also going to talk about drive space because drive space is the biggest nightmare you're going to deal with. We're going to talk about the full transaction log, and I've got some horror stories on that one. We are also going to talk about differentials, broken chains, backup loading, and then we're going to talk about the importance of backup testing and offsite storage. And that's the stuff we're going to cover. Now's a great time to run. If you think any of this isn't applicable to you, get out. This is your time. So let's talk about disaster recovery. As you can see, planet Earth's about to have a bad day. Now, most of the time when we're talking DR, we're not talking about something this horrific, but we are talking about the time, a friend of mine tells a story about the time that a truck drove through the wall of a data center. I know firsthand the stories about a data center that was flooding, and then another data center that was flooding, and another data center that was flooding. In fact, a lot of people put their data centers into 50-year flood zones. Probably a bad idea. And then put it onto the ground floor of the 50-year flood zone, or better still, into the basement of the 50-year flood zone. But the fact is disasters are going to happen, whether it's fire, flood, meteor strikes, or even just benign stuff. Someone switched off the SAN, attached storage, for those who don't know, which has happened to me personally. By the way, that one happened on a Friday afternoon at 5 o'clock as I was leaving the building. They switched off the SAN. And of course, I started getting alerts and all kinds of things. And yeah, Friday evening was no longer fun at that point. I had to go back right straight to work and keep going. Disasters are going to occur. Because disasters are going to occur, we need to assume this, right? Never assume everything will be fine. Nothing's going to happen. And the fact is something like this, yeah, okay, something like this isn't going to happen. And maybe the flood isn't going to happen. And maybe the fire isn't going to happen. But maybe the sand getting turned off does. Or maybe someone dropping a database by accident does. Or all the other horror stories I'm going to go through today, any one of these things could happen, at which point you are going to need to recover from your disaster, whatever that disaster may be. And when we're talking about that, the number one, the first, the basic, most basic aspect of a DR strategy, disaster recovery, is backups. If you don't have good backups in place, there's a great chance you're going to be in trouble. And the fact is that there are companies who have gone out of business. There's a long list of them. I actually wrote an article about it a couple of years back, that companies that just had no backups, or they said, oh, well, we have a SAN, which has, you know, multiple disks to protect you. And so therefore we don't need backups. The SAN is a backup. Well, until the SAN goes away. And then suddenly it's not a backup anymore. Or the people who had, you know, well, you know, we're fine, except that their databases were corrupt and corrupting worse and worse and worse over time until they went away. And they had backups, but they'd never tried restoring their backups. And so, guess what? The backups were corrupted too. The list goes on and on and on. So let's start with the basics. Let's start with the fundamentals of DR. Right, backups are not about high availability. They're not about always on or any of these fun things. And yeah, I said always on. Someone alert a friend of mine. Anyway, the whole idea here is that we need to take backups of SQL Server. Now, there's third-party tools that can do a backup for you. And you may find yourself working for an organization that says, oh, no, you don't need to run SQL Server backups. We have Tool X, and I'm not picking on Tool X. We have Tool X. Tool X is going to do our backup for us. And you say, okay, cool. Can you show me a restore? Just show me, you know, here's database A. Can you restore that? And when it takes them 3 weeks to do the restore, or 2 days, or 16 hours to restore, you know, 100 meg database or something, you know, ridiculous, you go, okay, cool. So what we're now going to do is start taking backups because Tool X is failing us. And if they're able to do a restore, you ask yourself, you ask immediately, you follow up and say, hey, cool, can you show me a point in time restore? A restore to say 15 minutes ago. And if Tool X can do that restore, if Tool X can do that point in time restore, great. Go with Tool X. You don't need to worry about SQL Server backups. Your company has done the due diligence, they've done the work, they're ready to go. If not, if Tool X fails, or worse yet, you are the new person responsible for databases in the organization, and you say, hey, how are we running backups? And I have received this answer. What do you mean backups? Guess what? If they don't know what your backups are, if they don't know what the backup strategy is, if they don't have any idea what that is, then you don't have them. And that means if you hit a disaster, teeny tiny disaster, oh gosh, we dropped a row of data, can we get it back? Giant disaster, we dropped the database, can we get it back? Really giant disaster, hey, the server's gone, how do we restore it? Okay, so first thing we've got to do is we've got to create backups. Now, backups, let's talk backups. First up, backup is not an export. A backup is a page-by-page transactionally aware copy of the database. Now, what do I mean when I say transactionally aware? Well, databases have these things called transactions that ensure that the data inside them is consistent, meaning it's stored correctly and it's a moment in time accurate. And so you don't get like, well, you know, 2 people were writing and we got half of this record and half of this record and no. One of them wrote first, one of them wrote second, both completed successfully. We have consistent data. right? That's the first thing you've got to have is consistent data. And so backups, which are not scripting your database because that doesn't include data. It's not a file copy of the database because that's not aware of the active transactions in the system. Nope, nope, nope. It is a page by page copy of the database. And that's the first and principal means of protection on your systems, is having that page by page full backup. And I use full backup because there are actually other kinds of backups. There's also a backup called differential. Now, differential backups, easy enough to understand, all of the pages that have changed since the last full backup. Okay, cool. Now that does mean that a differential backup is connected to a full backup. And so to restore a differential backup, you have to restore the full backup. This is really important, so make sure you get those right. Now you can do what are called file or file group backups. Now that's different from file copy. This is file backups. This is, again, using the backup mechanism to back up the files that make up a database. Now, this is a much more advanced topic, something you're probably not going to get into, but I like to mention it so you guys know it's out there. Now, the next thing you're going to have is a backup type called log backups. And that is the backup of the transaction log, the thing that tracks the changes that are occurring inside your database. Remember, we talked about being transactionally aware. Those transactions, the completion of a particular insert, update, delete, that's all part of a transactional backup. We have to keep those in order to do a recovery to a point in time. And that's your basic set of backups. There are other little bits and pieces, other little gotchas, other little mechanisms we could talk about, but that's the core. A full backup, a differential backup, all the changes since the last full, file or file group, and then log. And logs are all the changes, but they're not associated with a full backup. Those two things are separate. It's only differentials that are connected to the full backups. All right, any questions on any of that stuff? Anything come in yet? Nope. Cool, awesome. All right, so that's our foundation. We know what we're talking about now. We have backups. Now, let's start talking about the horror shows that can occur. So this is my first and favorite horror show. I do love this one. It's entertaining to me always. What you'll get is you'll see almost always the administration team that's done this. And what they do is they say, hey, you know what? We've got this backup product, right? So always backup product. There's always backup product X or backup product Y. We've got backup product X, and it's fantastic. It does all our backups for us. Cool. How does it do those backups? Well, it just walks through the entire drive on all the drives on the system and copies the files. Ah, cool. Is it aware of the fact that SQL Server locks all of its files, the MDF and LDF files? Oh yeah, we saw that it was locking the files, but we've got a way to copy the files that are locked. Oh, okay, cool. That's awesome. I'm glad you guys are doing that. Can you actually restore that backup? I mean, have you guys tried running a restore? Oh, no. And we did try it one time and it was all messy and all messed up, but we didn't really need it, so it was okay. What do you mean it was all messy and messed up? Well, the backup, I mean, we tried writing the file back, but then SQL Server didn't recognize that there was a file there. Okay, so you guys actually are corrupting your database files, and then when you try to restore, which you're not running restore, you're just trying to copy the file over, and wait. Oh, please list the backup types: full, differential, file, backup, or log. There's another one called partial, Monique, but basically don't worry about partial. Full, differential, file or file group, and then log. Those are the ones you want to worry about. So anyway, the file copy, what happens is that because the server's locking the files and because the thing is not transactionally aware, you hit issues and cannot run the restore because the restore doesn't recognize the files anymore. Now, the remedy here is to don't copy the files, run a real backup. Or, and this is a horrible remedy, don't do this, but I like to tell people that it's an option, shut down the server, then copy the files. No problem. Now, don't do that. I'm not serious. Don't do that. That's a joke mostly. But that would work. It's just means that your server's offline while you're running backups. And if we just ran regular backups, we would not need to do these weird shut down the server things. So let's just not shut down the server. Let's run real backups. Now, what you could do in an emergency, you could try. You've got the MDF and LDF files, the files that make up the database. You could try running what's called an attach. Chances are it won't work, but you could try it. And even if you throw away the LDF files, if you just have the MDF files, the data files, you could still try and attach and rebuild the LDF files, but chances are that won't work either. So your best bet is to run normal backups and not try to run file copies. This says file backups, it should say file copy. I'm going to change these slides at some point. Any questions on this one? Nope, I don't see any. Cool. So our next problem number 2, drive space. Oh my God, I hate this one. So previous employer, not my current employer, previous employer, they offered money to be on call. And it was small money, it wasn't anything big, but it was still extra money. And so I took it. I'm more than willing to work harder and be on call. I'm happy actually to make some more money. So I'm like, I'll be on call, no problem. But I was not a system DBA. I was a database developer. I was responsible for working with the dev teams, building new databases, query tuning, database design, server design, a lot of architecture work, but not the fundamental day-to-day managing the systems. And so what was going on was the people who were responsible for the day-to-day management of the systems, well, they weren't on call. And so they kind of didn't care that, 3 to 4 nights a week, the backups failed, and we would get an alert because we maintained a monitoring system, and we knew if our backups failed, because you want to know if your backups are failing. So the backups were failing. We would get errors on backups. We would also get errors on drive space. And one time, I love this story, it's fun. One time we had an outage. We had a real problem. Someone accidentally, it wasn't me in this case, someone dropped a table in the database. Problem. No big deal. We can go to the backup, we can recover it. We might lose a little bit of data, but I'm sure we can recover it. And come to find out, the backup drive had been full, and it wasn't one that we were monitoring appropriately. And by the way, that was on me and a couple of friends. We'd messed up. But we weren't monitoring our drive space. We weren't monitoring backups on this particular server. And sure enough, when we needed them, they weren't there. All kinds of problems. All kinds of problems. So the cause of this issue, the cause of the drive space issue, 1, we're not monitoring our drive space. We're not keeping an eye on how much space do we have on our drives. And that's something we have to do. 2, we're not keeping an eye on our database growth, because databases almost always get bigger. It's kind of the nature of the beast. They're going to grow. You're going to get more data. Very few organizations have less and less data over time. Exceedingly few, probably 0, but very few. Let's just go with very few. But most companies, most organizations are going to have more data, more data, more data, more data. And so database size is going to increase, and therefore the size of a backup is going to increase. Even if you're using compression, even if you're doing all these good things, you can still have an increasing size, and that's going to cause you to run out of drive space. So what do we do about running out of drive space? Well, number 1, monitor the drive space. Make sure that we're keeping an eye on how much space we have, and that we're running backups to a place that has enough room so that we know that we're getting the backups we need. We have to have those. It's really important. The second thing we can do to mitigate this issue is clean up our backups. Let's say because different organizations are going to do things different ways, and there's not one true path. But let's say we're running full backups once a night. Well, how many of those do we need to keep? Well, okay, I don't know. Are we also running transaction logs during the day? Are we running differentials during the day? Yeah, we're also, let's say we run differentials twice a day. Well, probably we only need to keep 1 or 2 of the backups. Oh, we've been keeping 2 weeks worth. All right, well, let's chuck a week's worth, or maybe even only keep 2 days worth or 3 days worth or something else. Let's clean up the backup files that we have so we have more disk space so that the hot stuff, the stuff that's going to be an emergency, and it's always going to be at 3 a.m., it's always going to be the latest and greatest stuff. Let's keep an eye on that and make sure we're ready for that. Finally, point number 3, monitor the database size. Keep an eye on the size of our databases. If they are increasing, you know your backups are increasing. Therefore, you're going to need more drive space. So you're going to have to keep an eye on this stuff. If you're in an emergency, guess what? If the backup failed because there was no drive space, you don't have a backup. If the backup failed because there wasn't enough room to store it, you don't have a backup. There is nothing you can do. If you do not have a backup, the emergency is go write a new resume. That's really kind of it. I mean, you don't really have a choice here. You must have a backup in order to run a restore. It's that simple. Any questions on this one so far? Nope. Okay, cool. So the next problem we're going to run into, very, very common, is the full transaction log. Those transaction logs fill up. Now, what you're going to see, the indications you're going to get from this is you're going to see that your transaction logs or your drives, probably your drives, are constantly nearly full. And you're always going like, oh my gosh, our drives are full, or you're going to get an error. You'll get the transaction log will fill the drive. It will have no more room to grow, or you'll have turned off auto grow, and therefore it can't grow. But you will get an error and the transactions will stop in that database, meaning the database can still run queries, but it can't update data, it can't insert data, it can't delete data. And yeah, that's a problem. There's going to be all kinds of things. You're going to hear, if nothing else, you might find out about this one by the phone ringing. And let me tell you, the phone ringing is the last thing you want. You always want the alerts to tell you there's a problem. You don't want the phone to ring. So the cause here is that once the transaction log is full, there's actually not enough room because the transaction log has to be able to write to the transaction log in order to truncate the transaction log. And the transaction log gets truncated on a log backup. So you're going to fail, right? The log backups have failed either because the drive is full or because it's just you've got a lot of transactions, or worse yet, you put your database into full recovery mode and you never set up log backups. Eesh, that one's really, really common. Actually, if you go to my blog and type in, why is my log full? I have at least 2 blog posts answering that specific question because this is so common. This is such a common problem. So how do we remedy this? Once we know what the indications are, we know what the causes are, the remedies are pretty simple. 1, make sure that if we are in full recovery, we have log backups set up and scheduled. Also, make sure that we are tracking the size of our logs. If our logs are constantly growing, we need to make sure we're dealing with the fact that they're constantly growing by running log backups, or maybe even running our log backups more frequently, or we need more drive space, one or the other, but we've got to make sure that we've got log backups in place. We've got to make sure that we're monitoring the size of those logs. If you do not need full recovery, meaning you don't need to take log backups, then switch your database to simple recovery. And then you don't have to worry about the log backups. The log file could still grow, it still could get big, but that's a natural extension of transactions, and that's okay. What we really need to do is make sure that we've got a log backup in place. Now, what's the best practice for saving log backups? On different files, or append them to one file and then have the whole file daily? All right, this is one of those things like, where do we put the commas? at the end is the appropriate answer, but a lot of people don't agree with me. I'm sure there's probably half the presenters just freaked out because no, you put them in front. But anyway, do we put logs all into one file? And when we do backups, we can stack the backups into a single file and then manage a file, or we can have the backups across multiple files. Personal opinion, and I don't have anything strong to back this up, Elvin. I'm sorry, I really don't. Individual files. I just find it easier to identify what's going on. There's fewer steps to see physically where we have backups. And by the way, a naming standard on your backup, so that you say, this is the database, this is the day, the time of the backup, so you don't have to try to figure that stuff out. As a file name, you can literally open the File Explorer window, look, and see. That's why I like it. Is it the single best way? Are there weaknesses? Sure. You could hit some corruption on individual files and it causes issues, whereas if you've got one file, you won't hit that corruption. But then again, if you've got one file and it's corrupted, then it's gone. So I lean towards multiple files, but I won't die on that hill. If somebody really feels strongly that we have to have a single file, I'd let them have it as long as we write all the scripts so that we can take advantage of it. But I really like using that Mark I eyeball to look at things and see what's going on. It's just the easiest way to work. Hopefully that answers your question. Now, so we've talked about the remedy, the emergency. What do we do? The log's gone. The log's full. We've got an error. We're not getting backups out of it. What can we do? If we're in a screaming emergency, what we could do is try attaching an additional log file. But even that act requires a little bit of space on that log file, on the log drive or wherever the log was stored. A little bit of space. So here's a tip, little trick. Put a small file in, like say 5 megabytes, nothing, like empty space, a 5 megabyte empty file, right? It's got 5 megabytes worth of spaces in it or something, but it's a little tiny little 5 megabyte file, and name the file delete me in emergency. That's it, nice and simple. And then when your log file is full and you need to do that last little, can we try a log backup? Can we try a log truncate? Can we try attaching an additional log file? Yes, we can try any one of those things, because what I'm going to do is delete the little 5 megabyte file and I've got just a little bit more room. Woo, we win. That's my strong recommendation there. Is it's a little bit of paranoia goes a long way when you're administering databases. Any other questions? Nope, don't see any. Cool. We will keep going. All right, next up, differential only. This is fun. So what happens is people get really enamored of differential backups and they will run them exclusively. They will take a full backup once and then they'll run differentials for the rest of time. And I've seen 3-6 months of differentials sitting around. And yeah, so you go to try to restore a differential without a full, and you just immediately get an error. There's nothing you're going to do. You get an error. And so, well, wait, what's the problem here? Well, we lost the full backup. What do you mean you lost the full backup? Yeah, we lost it. It's gone. We've been running these differentials for the last 3 months. Okay. We have to have a full first. We have to run the full database, and then we leave it in what's called a recovering state, and then we can run the differential, and then once the differential is complete, we can run recovery, and that will complete the restore process, and ta-da, we win. But if you don't have a full backup, or you ran the full backup, but you let the database recover, you ran it with recovery, you can't then apply differentials. Now that one's easy to recover from. Rerun the full restore, but use with no recovery. And then you can apply your differentials. Yay, we win. But if you don't have a full backup, guess what? We are, yeah, if we're in the emergency, right? Okay, Grant, cool, we still don't have that full backup. What can we do now? Nothing. Without the full backup, you're stuck. You've got to have the full backup in place. It's just, that's the nature of the beast. There's no getting around it. So get that full backup in place and have that before you need it, right? That's another key. Have it before you need it. Okay. The next issue that's going to come up very frequently is a broken backup chain. And now this occurs not with logs. A lot of people consider this to be a log problem, and it's not a log problem. It is a differential problem, because logs don't care what full backup is as long as the transaction numbers of that full backup are contained within the logs, and then we can run them in sequence. The logs are easy. Logs are really easy. A sequence that covers the full backup. That's all we need. Any full backup except snapshot. Well, no, snapshot. Yeah. Let's go with any full backup for the moment. Someone will probably correct me at some point. Anyway, their issues we're going to see is that we're not going to be able to recover again because it's going to give us an error, and the error is going to say, hey, no. This full backup doesn't match this differential. Oh no, now what's the cause there? Well, one, maybe you picked up the wrong full backup. Go and find the right one and restore it. Oh, cool, fixed it. Or, and this is really common, my junior DBA, I always call my junior DBA Tim. Not because I had a junior DBA Tim, mainly because I never had a junior DBA named Tim, so therefore I'm not picking on an individual when I use the word name Tim. My junior DBA Tim got the word that, hey, the QA team would like to have a new restore of production to do some testing. And so Tim went into the production server and ran a restore in the middle of the day, manually. Guess what? Now, when our next differential runs, is it connected to our nightly full backup? No. It's now connected to your new backup that Tim created. But Tim didn't keep that backup. Tim got it, restored it to QA, cleaned everything up so it was good to go. And then, hey, Tim's a good, responsible person. He threw it away to make sure that that extra backup wasn't stored on our disk, taking up disk space. And by the way, this is a real story. That really did happen. Not to me, to Tim. And sure enough, we had a problem because, of course, we did, and we could not run the restore, and we lost a day and a half of data. We lost the day and a half of data because we didn't have the right full backup. So what do we do instead? If we're running a backup for an emergency, right? Oh, we're getting ready to do some change to the database. Well, if we've got the right version of SQL Server, we run a snapshot backup while we make that change. And then if we have to do an emergency restore, we don't do an emergency restore, we undo the snapshot. Yay, we win. Now that's enterprise only. You may not be able to do that for everything. So fine, we do a backup and use the command copy_only. Copy_only. That way, it knows, hey, we're making a copy of the database. This isn't an official full backup. Therefore, I'm not going to mess up the chain. I'm not going to make it so my differentials won't restore. Now, if you're in a screaming emergency, if you've also taken log backups, use those instead of the differential. And this is why you may want to have log backups going back further than your differentials. It's probably a good idea to keep log backups all the way past the last full backup so that you can always connect up to that full backup with the logs and run the restore that way. So if you hit the situation where the backup chain is broken, try hitting the log backups if you have those, okay? No questions that I see. Cool. Next up, the wrong server. And oh yeah, I did this. So the indications, the phone's ringing. So I was asked to, again, restore to the QA team. So, I went and grabbed a copy of the backup. My name is not Tim. And I ran restore, but I wasn't looking and I wasn't paying attention. And This was before we set up security correctly so that production had one kind of security and non-production had a different kind of security. And so, yeah, I ran a restore of the database to the production database. I realized what I was doing while it was running. I messed up. What can I tell you? And yes, normally if there's open transactions, you wouldn't be able to do that, but I managed to hit the button at God knows the perfect moment, and I got through. Horrible, horrible moment. But yeah, sure enough. Now I'll tell you another story. This was Tim. Tim, again, before we set up security, and we did set up security after this one. We should have set it up after the first one, but we didn't. And we set it up after the second one. Tim thought he was running a restore for the QA team. And this was funny because I heard this one. He went, "Oh, darn," except he didn't say the word darn. And I said, "Well, what's wrong?" He goes, "Oh, I'm sure it's the right server." And I'm like, "What, what's wrong?" He's, "I'm sure it's the right server." I said, "Well, what's wrong?" He's like, no, I'm sure it's the right server." I said, "What do you mean you're sure it's the right server?" He's like, "Well, I'm running a restore and I'm not sure it's the right server." And sure enough, he ran a restore on production. But how did he get through? Well, Tim didn't like the QA team because the QA team would ask for a restore, but then they would be logged in and they would be running transactions. And they'd say, "Hey, we want to restore," but they'd also be running queries. Well, while they're logged in and connected and running queries, we can't restore. So Tim had a habit of doing setting all the databases to single user in the QA. He had a script, set the database to single user, and said with rollback immediate. So it rolled back all the transactions. He got single user, and then he ran the restore. Well, guess what he ran the restore on? Prod. Yep, production. He ran production restore. So we know the indications. The phone rang, or Tim says, "Oh no." We know the cause. We just ran it on the wrong server, and we probably used with rollback immediate, which I would be really, really cautious about that one. If you're supporting multiple teams, don't try using rollback immediate to fix stuff. Just call them, talk to them, and communicate with them. So how do we get around this? First up, avoid the problem. Use different security for production. Force yourself to have to log into the production server in order to run a restore there. Don't make it so that if you could accidentally run something on production. That should never happen. Second, Management Studio, SSMS, has the ability to color code servers. And there are third-party tools that do it even better. But the Management Studio can color code servers. Color code the production servers, make them red, make them green, make them, if you're blue-green colorblind, make them orange. I don't know, make them a color that's going to stand out to you so that you can tell when you're connected to server A versus server Q. And if it's server Q, it's QA and we're great. And if it's server A, it's production. And oh my God, don't run the backups of the restore script there. Also, I'm not a fan of rollback immediate. I see that there are reasons for this, but we may need to do it. So let's be very cautious about it. And what do we do in an emergency, right? We've got the basic, we've got the indications, the cause, the remedy. What do we do in an emergency? Well, it's an emergency, all right. What I did and what we did with Tim was first we let our boss know, boss screwed up, made a mistake. That's step one. Step two is start running a restore. Now, if this was a dev server, and by the way, I did do this on a dev server one time too. If it was a dev server, I'll just tell the dev team, hang on a second, there seems to be something wrong. Let me work on it. Oh yes, there it is, fixed it. Yeah, so it's dev, we can cheat a little bit with the dev team. It's no big deal. It's not production, right? We're not cheating with production. But on a production server, what we do is that you immediately go to your last good full backup, apply that. If you have differentials, apply those. And if you have log backups, apply them up to the point of time in which you messed up and effectively drop the production database by running a restore in the wrong place. Now, a question came in, it said copy only. I can't quite read. What did you write there? Oh, it's just all about making sure you don't break the backup chain. Yeah, it's all about being able to make a copy of the backup, a backup of the database without affecting the chain for the differentials. And it's just Why would you need it? I don't know. It depends on different reasons. For example, we wanted the QA team, for some reason, had the ability to request a new backup on demand. So we used copy only to ensure that we weren't breaking things when they asked for it. That's a whole nother discussion as to why they could do that, but that's how that one came up. Okay, wrong server. By the way, this one's common, so please do what you can to avoid this one. It's far too painful to deal with, so try to avoid it. It just hurts. Next up is backup load. The fact is you may see indications of excessive CPU, or you may see a lot of I/O contention, input output, disk contention. You may see a lot of that. You may see very excessive CPU or very high I/O contention. You might see a lot of waits on backups. Now, backups, by their nature, by their design, are meant to not be blocking. But the fact is everything can block to one degree or another. And so you may see some blocking going on. These are your indicators. If you can say that, look, we're seeing lots of waits on backups, we're seeing lots of I/O, it's entirely possible that we've got excessive load on our servers and backups are becoming difficult. It happens. Now, in this case, things get hard. I mean, it's just things get hard. This is not a simple thing. There's not a, oh, it's no big deal. Just flip this switch and add this command and your backups now won't run slow anymore. Nope. The backup, if you're running a full backup, it's dependent upon the amount of data that you're backing up, the load on your server, the speed of your disks, the speed of your network, assuming you're moving it across the network to any degree. Any or all of these things are going to affect the way the backup runs. And so any or all of these things are the cause, and yay, any or all of these things could be the remedy. If your disks are slow, get more disks or get faster disks. If your network is causing the problem, maybe back up locally and then copy the backup and let that copy take a long time. Who cares? But you're going to have to get over the fact that the load is high and there's just no way around that. There is another remedy. If you are in an availability group, you can run backups from the secondaries in an availability group. It's a little bit sketchy, but it does offload the load from your production server. In an emergency, do whatever you have to do. Now we've got 8 minutes left. Cool. Just wanted to check. So those are the basic, core, fundamental, most common problems that you're going to see. There's a bunch of other ones, but here's the deal. Kimberly Tripp, as far as I know, is the first person to say this, and I'll back that up to a hilt. You are only as good as your last restore, right? Backups are great. Backups are nice. Backups are wonderful. But if you cannot restore your backups, you are going to fail. So here's the deal. We have to test our backups. Now, how do we test our backups? Well, obviously, we're going to run DBCC, Database Consistency Check. We're going to run that against our production database. We can also run it against restored databases. If you restore a database and you can run DBCC against it, that will tell you whether or not there are logical errors inside that database. Now, physical errors, you have to still run it on production, but there's ways to break DBCC down into multiple steps to have to cover that issue. That's one step of a backup. The next step of backups is that there's a thing called checksum. When you run the backup itself, you can tell it to checksum the writes. And what it's going to do is it does a little calculation and says, hey, what I should see after writing this is this value. And so it will do the write, it will compare the write to the checksum and say, hey, look, it works. Awesome. But the checksum can be violated in ways that you can't catch, or the internal database could be a problem. So checksum's not the only thing. DBCC, 1, checksum, 2, neither is complete. So 3, verify only. You can run a restore verify only. And what it will do is it will check the header, and it can run with or without the checksum, and it can look at and say, hey, if I ran a restore, would this work? And that's going to tell you most of the question. Will a restore work? Well, unfortunately, there are holes with verify only. There are certain situations that verify only won't be able to cover, and therefore a verify only restore doesn't fully test. So how do we test a backup? The full test, the perfect test, is a restore. Just like nuking the site from orbit, it is the only way to be sure. A full restore is the only way to fully test your backups. So a very good practice is to set up a mechanism to run DBCC checks, to run checksums, to run verify only, and to run restores on a regular basis. That is how we test our backups to ensure that we meet Kimberly Tripp's answer. You're only as good as your last restore. Okay, a couple of questions came up. First restore the full, then the logs in order. So why is there no connection between big files and full backup? Sorry, I don't quite understand that. Yeah, I'm sorry, I don't quite get that one. If you want to try to rephrase it, we can talk about it. Here's another thing that we should be doing to protect our backups. Offsite storage. Now, I don't care if we're using the cloud or whatever. A second drive, a second server, a second copy, multiple copies, a third copy, at least one copy off-site. And all of these have to be encrypted. You need to encrypt your backups to ensure that your backups are protected. And so this is just fundamental stuff. You've got to have a second offsite storage, because if you're just putting your backups on the same drive that the log files are on, when that drive goes away, so do your logs. If it's on the same server, if that server causes problems, you could lose everything. If your site, if you do get that meteor strike, you could not be able to run a restore because the restore's gone. And I don't care if it's if it's in the CEO's filing cabinet, if the CEO takes it home at night, if your boss takes it home at night, or you put it up on the cloud someplace, have a second copy off-site and make sure that that second copy is encrypted. That's it. That's what I've got for your fundamentals on database backups and the common problems you're going to run into. We've got what, 2 minutes left? Are there any questions?
I think we have one more question about the benefit of running log backups on a secondary server. So I said that would be less strain on I/O and then less strain on the CPU in the case of compression. Did I miss anything there? Is there any other reason you might want to do your log backups on a secondary server?
No, the only thing I can think about is offloading this. It's offloading the work, right? You're moving the work to a secondary place. I mean, it does have some risk because there's always going to be a certain degree of latency, and so you're getting backups, yes, but you could still lose transactions because it's just a little bit behind the production system. But at least you're taking the backups. I mean, losing 5 minutes is so much better than losing 5 hours, 5 days, or 5 months. And I've seen people lose 5 months. It's just a nightmare. By the way, there's several articles on here. SQL Server Backups, Backup and Restore for the Accidental DBA, and then I've got a bunch of backup on my blog. If you go and look there, you can track them down. This is my contact information again, just so you guys have it. We've got a minute left if you want to ask any other questions. If not, I can end a minute early and have the next speaker get set up. Anybody want to type a question in? We will do our best to answer it. Hey, I see Glenn Berry.
Yes, pretty soon everybody will be seeing Glenn Berry.
Oh, you guys are going to be happy. This man is amazing. And unlike me, he's actually smart.
Oh, smart in making beer, perhaps.
Smart that you're making beer.
Yeah.
Well, okay, so I'm all done. Thanks everyone for attending. I sure hope that was helpful. Again, if you've got questions, you can track me down. Otherwise, I'm going to stop sharing my, oh, you've already taken it away.